Hello, everyone. Welcome to today's webinar. Thank you for joining us today for Find Your Watershed Footprint and How to Tread Softer on Water Resources. My name is Alexandra Ramirez. I am part of the social impact team at Xylem, or how most of us know it, the Watermark team. And I'll be your host for today's session. And thanks again for being here. I see more people are joining, so we'll give it a few minutes for others to join. And I apologize if there's a lot of noise. I lost internet connection at home today, so I'm at a coffee shop, and the garbage truck just came outside, so I am so sorry for that. These things happen. I'm going to mute myself for 30 seconds, and once they're gone, I will unmute myself. That is so funny. The noise isn't too bad? Okay, perfect. Thank you. I will continue then. Great. So, next slide. As most of you know, this webinar is part of Xylem's second signature event of the year, which is called the Protect Your Watershed Bingo Challenge. It's a 2-month-long initiative where we invite everyone to take simple, meaningful actions that protect water in our communities and around the world. And getting involved is really easy. So all you have to do is just download your watershed bingo board and start taking simple actions to protect your watershed. And great news, starting with this webinar, that's right, by attending today, you can cross off your first square. And the best part is that every action that you take during these 2 months helps trigger a donation to nonprofits working to protect and restore watersheds all over the world. So it's a fun way to make an impact. So grab your bingo board. Now you can scan the QR code or after the session and visit the Xylem Watermark website to learn a little bit more. So to kick things off, we're excited to welcome back Dr. Scott Ensign from the Stroud Water Research Center. Scott is a returning guest who's been a great partner to us over the years. Today, he'll introduce us to Model My Watershed, a science-based interactive tool that helps you visualize the human impacts on your local watershed and identify ways to reduce your footprint. Scott Ensign is an ecosystem ecologist studying how interactions among plants, animals, and microbes in rivers influence human relationships with freshwater systems. He conducts biochemical research, develops new measurement technologies, and explores the impacts of sea level rise and conservation strategies on river ecosystems. Today's session will run about 40 minutes. We'll have time at the end of the session for questions, so please don't forget to drop yours into the Q&A and comment section as we go. So with that, and now that the garbage truck is gone, Scott, I'll hand it over to you, and welcome back, and thanks again for being here.
Okay, thanks very much, Alex. You can see my screen and we're all good?
Yep.
All right. Well, thanks very much, everyone. It's a pleasure to be back here again, speaking with you all to share some news and science from Stroud Water Research Center. Thank you all for joining. I'm looking at the list of geographies, and there are people joining from all different time zones. So thank you for tuning in. A few little introductory information about Stroud Water Research Center. So our mission is to advance knowledge and stewardship of freshwater systems through research, education, and watershed restoration. And we do our work around the world. And we've been doing it here since 1967. We're based in southeastern Pennsylvania near Philadelphia. And the core of our operations is water science. Over the years, we've added programs, educational programs, and watershed restoration programs and technology, which will kind of be one of the focuses of my talk today. But at the core of everything that we do, it's about science. It's about advancing water science and advancing the knowledge that produces for society. So we've done this for many decades now. We've got a lot of experience and a lot of stories to tell about how we've seen the world change for the better. So the core of what we do is really Sustainable Development Goal 14, but it's very hard to separate what we do, life below water, from climate change, from life on land and clean water. All of these things are really interlinked and interwoven. It's hard to do one really well without touching on the others. And so you'll see that today in my presentation, that what we do is really interwoven throughout the water cycle, which includes climate change and atmosphere and drinking water and all the other resources that water and life underwater provides to us. So let's start with a quick quiz. Let's see how we do here on just understanding what a watershed is. So a few questions, and hopefully, yeah, we'll see some poll results to see where we're at with what a watershed is. And I don't have a good view of the answers. Maybe Alex, could you give us a sense for which of these three answers is getting the most attention?
Let me see. You guys, can someone confirm in the comments that this was launched? Just want to make sure this was. Okay. Looks like it is.
Any answers visible?
Not yet until I close off the poll. Let's see.
While we're waiting, the correct answer, for those who haven't excuse me, completed this yet, is number 2. So a watershed is just a geographic boundary in which water flows downhill past a common point. And when we think of rivers, we think of a point in the river, a point along that river that water is feeding into. Checking back in with Alex. Any summary of results?
We do. So it looks like 86% of our attendees, 93% of our attendees now responded correctly. 7% said a shed in your backyard. Yep.
All right, very good. All right. So let's talk more about watersheds, because watersheds are really central to what I'm going to talk about today. They're central to how we think about water in general. So understanding for every point on the earth, the watershed that point drains is really a fundamental step in almost everything we do related to river science, to water resource management. So I want to share with you a tool that you can, if you have the capacity, you could do this right now as we're talking. You can go to modelmywatershed.org, and Jess will maybe throw a link in the chat just to clarify that. When you get to this website, you'll see the splash screen, which I'm showing you. And you can play around with visualizing the different layers there if you just want to use it as a mapping interface. But click the Get Started button. And if you're watching a recording of this and following along, I want you to click the Get Started button down there. And it's going to take you to this screen. And there's 2 things I want you to do next. On the left-hand side where it says Delineate Watershed, there's a drop-down list. I want you to click on that drop-down list and select Global Basins from TDX Hydro. Now, this is going to work for every one of you around the world in your geography. There are additional options, and there's a little bit more resolution if you're within the United States. You could click the Continental US NHD Plus V2 layer to do this. But just for starters, let's go with that Global Basin set. Navigate on the right to a geography that's meaningful to you. This could be your town, your city, your favorite river to paddle, somewhere around the earth. And then if you click on the layer This is what I'm highlighting on the right-hand side in my window, the global stream network from TDX Hydro. You'll see water river channels visualized there on the map. So once you have that in front of you, maybe you're following along, depending on how fast all of our internet connections are working, you may be able to do this as I'm talking here. But the next step, if you click on a point on that map, click on part of one of the blue lines, the Model My Watershed is going to delineate the watershed upstream from that point. So this is where it all starts. Pardon me. This is where it all starts with water science and water management. We're going to start with an understanding of where our watershed boundaries are. And maybe you're getting a result now for that. And Model My Watershed is first of all going to show you some really helpful information. First of all, what's the total length of streams that are in that watershed? This is fundamental to kind of how we start thinking about a watershed. What streams are within that watershed? What does the stream network look like, which you're visualizing right now? Some additional information that we're going to see in Model My Watershed is what land uses and land covers are we looking at? So how many crop acres are there? How much built area in cities are there? There's a lot of additional features here, which I'll share with you a link that you can learn more. I'll share that at the end of this presentation, just so we can move forward. But this is a really powerful tool. We're going to come back to this tool, modelmywatershed.org, but it helps to have the starting place. If you're interested in your favorite river, in a conservation area that you care a lot about, your town, your city, your municipality, start with this. Start with understanding where your watershed boundaries are. What's in your watershed? What does the land use look like? And then we can start talking about what's the life underwater, which is what we all care about. That's why we're here. We care about the life in the water. We care about the quality of the water. So let's talk about that. So biodiversity, streams and rivers, although they occupy only 1% of the surface of the earth, so they're a tiny fraction of what's on the earth, but they hold an incredible amount of biodiversity. 140,000 species of insects, macroinvertebrates, fish, amphibians. So there is an enormous biodiversity in streams and rivers. Unfortunately, a quarter of these, particularly the fish and the amphibians, are threatened by extinction. So streams and rivers and the animals and plants that live there are incredibly exposed to the pollution that we generate and the degradation of our environment. So a tiny little, very rich reservoir of biodiversity that's very sensitive to pollution. But there's good news. Since the 1970s in the United States with the Clean Water Act and the European Union, other developed countries have added water protections. Our streams and rivers have gone from generally really poor condition. Into the 1980s, we made a ton of progress. Things were looking really good. We had gotten from poor to, generally speaking, fair. We were doing a lot of good. Since the 1980s, progress has kind of leveled off here in the United States and elsewhere around the world in developed countries. We made a lot of progress initially, but we've gotten to the really hard part. It's like getting this last, 90% of the way towards good, where we want to be, has turned into an incredibly difficult challenge that's being made even more difficult because we keep adding impacts. We keep developing our watersheds. We keep generating new pollutants and chemicals. So this is making the process much more difficult as we go forward. And I'll talk about that and some of the solutions. And that's kind of why we're here today, is to figure out how to push this, past this final goal of getting all of our streams and rivers into this good category. So let's go to another quiz question. And, there is, as Alex pulls up this quiz question, I'm going to say there are a lot of things we could talk about today, but in a short amount of time, the things that I want to emphasize to you are some of the basic impacts to streams and rivers. We could talk about PFAS and pharmaceuticals and other emerging contaminants. We could talk about road salt. We could talk about industrial pollutants. There are so many chemical compounds in our environments that we could talk about. But I'm going to focus on some more fundamental ones that maybe you don't think about as commonly, but which are really important to the simple things that we can do for streams and rivers. So we're getting some results in. Good, and we can see this in real time.
Yep.
Great, and good. And so
97% have said all of the above.
yeah, and that's the answer that I wanted everybody to go with. So congratulations, everybody. That's right. What we're talking about here is really two things. We're talking about sunlight, heat, and we're talking about water. And by water, basically what we're talking about are floods and droughts, the balance of the hydrologic cycle, and the impacts of climate change. So we don't often think of these as stressors, but they are very fundamental to stream environments, to plants, animals, fish. So we're going to talk about these two kind of basic impacts to streams and rivers today, because they set the stage for ecosystem recovery in lots of different ways. In other words, if you don't address these two things, solving pharmaceutical problems and industrial chemicals and all those other things that ring the alarm bells that we think about in the news today, you can't make progress unless you address these two fundamental things. So I want to talk to you, and we're going to start with talking about heat, okay, which is basically sunlight. How much heat is going into our rivers? And it turns out that, not surprisingly, too much heat is bad for animals that live in streams in the same way that it's bad for humans. In the same way that we have heat waves in our environment, we have heat waves in rivers and streams and estuaries too, and we can measure that. It's become a phenomenon that we're tracking, are these aquatic heat waves. And why are these bad? These are bad because they're affecting the organisms that will live there, particularly macroinvertebrates. These animals can't regulate their own temperature. So whatever temperature the water is, that's what temperature the organism is, and their behavior, their metabolism, their growth, their reproduction are being affected by that heat. So that's why it's really important that we pay attention to heat. Just as an example, the Stroud Center's done a lot of research on this for many, many decades. And one of the simple examples that I can share with you is research on this mayfly species that we've done a lot of work with, to understand how different temperature regimes in streams affect its growth, reproduction. So here's an example in which, when you elevate stream temperature beyond the normal threshold for these animals, they start to grow faster, but they're going to grow to a smaller size, and they're also going to produce fewer viable eggs, and they're going to have problems with reproduction. So obviously you're affecting not only the organism, but now you're affecting the population. And as you affect the population of one species, you're altering the ecosystem dynamics of many others. So temperature, this very simple temperature regime, is critically important to not only macroinvertebrates, but also fish as well. And with fish and other vertebrate species, what we see is that when you get temperature into certain thresholds, it starts to stress the fish. And we can measure those stress hormones the same way that we can measure them in people. It's just as real in vertebrate species underwater. And stress causes changes in behavior, which ultimately change populations, ecosystem dynamics. So heat, in this sense, is a real problem. So how can we deal with it? Well, number one, we can put trees back alongside rivers. In most places around the world, in many environments, trees were the native riparian species next to streams and rivers. And they play a crucial role around the world in not only shading streams and rivers and keeping that temperature in check, but also providing habitat and providing resources. So a lot of those macroinvertebrate species, like we just talked about, the mayfly species and others, they're basically, in many ways, dependent on the leaf litter, the organic matter that the forest provides to the stream. So there's a lot of interlinkages, but it goes back to the fact that we need to put trees back alongside our streams and rivers. So how do we do this? Well, we do it by planting trees, but sometimes that takes regulation. Sometimes it takes changes in zoning. It takes an emphasis on open space, on investment in open space, decreasing impervious surfaces, and restoration. So let me give you an example. Again, right from the Stroud Center, we've done work on this effect of riparian tree plantings for many, many decades in many different ways here. We have the benefit of having a stream right outside our back door that we've done a lot of work on. What I'm showing you here is temperature from this week at two different parts of our stream. On the left-hand side is a picture of what was decades ago a cow pasture. Well, we took the cows out and we planted trees. The picture on the left shows you yesterday what that stream looked like. Tree canopy is almost completely shading the stream versus what it used to look like many decades ago. On the right-hand side, downstream, there's a pasture where we don't have any cows there anymore, but we've kept the trees from growing in an experiment. This is an experiment to understand the role of those trees on temperature and ecosystem dynamics. And here's temperature data from this week. So you can see that, there's this change in temperature throughout the day, cooler at night, hotter during the day, but that pasture land warms up faster because it doesn't have any shade. This makes sense, but here's the data that proves the role of trees on cooling the stream, among many other things that it does. So we have these long-term data sets to demonstrate this process. It takes time. We'll come back to that. It takes time, but we can clearly change the stream for the better by putting those trees back in place. What's another way we can offset heat? We have these big parking lots in our urban environments. We have parking lots everywhere. And that water, particularly during the summer, particularly in places here in Philadelphia, those parking lots and that asphalt get really hot. So you have a summer rain event, it puts water on that pavement, it gets really, really hot. And then that water runs right off into our streams. And that's a shock to the animals and plants that live in the stream. You're dumping a lot of heat into the stream very quickly. And for the reasons that we talked about, that's really bad for the animals and plants that live there. So the simple solution is don't add that water, provide a buffer. We'll talk about ways to do this, but you can collect that water in retention basins, you can let it cool, you can pass it through different ways to take the temperature out of that water before you put it in a stream. This picture on the right-hand side is like the worst case scenario. You've got a big parking lot, you've got a little gravel run, and then it goes straight into a concrete channel, which then goes into the stream. It's like all the wrong ingredients for how to be good to our streams and rivers. And then finally, so stepping back. So let's think about our watersheds. What are we doing? We're protecting the streams and rivers, but we're also putting that water back underground. What we want to do, I'm going to emphasize this throughout the rest of this talk, what we're trying to do is get water back into the ground, not let it run off our fields and farms and cities, but get it back and soaking into the ground, into our groundwater. Think of that groundwater as like a bank account. That is what we're going to draw on during summer, during droughts, as climate change affects our streams and rivers. That bank account of groundwater is what's going to save our streams and rivers. So we need to build those up. We need to protect that area, and we need to get water back into the ground. We'll talk about more how to do that as we go forward. So we've talked a lot about heat, but let's now turn to hydrology. Again, you might not think of hydrology and rainfall necessarily as a pollutant, but it is in several different ways. And we're going to focus just now on floods and droughts and events. So precipitation intensity is increasing in the United States in different places because of climate change. One of the places that I would urge you to go check out is climatecentral.org. If you haven't been to that website, it's a wonderful website, lots of rich information, lots of detail, lots of science and data there in a digestible manner that help people understand what has happened to us in terms of climate change, but what we expect is going to continue to happen over time. So flooding is a problem. We're getting more and bigger floods over time. But we can also talk about individual events. So remember the difference between weather and climate. So weather is kind of like what you choose to wear today. But climate is like, what are all the different clothes in your wardrobe, right? Or weather is kind of like, what's your mood today? But climate is more like, what's your personality? What's the mix of all of your moods over time? So it's important to distinguish between weather and single events and climate. So you can think about those analogies. But another really good website that I encourage you to check out if you want to dig into this in more detail is worldweatherattribution.org. Good website where they go and they drill down on single weather events. And they attribute how much of that intensity of that event was due to climate change. So some really interesting analysis. But what I'm showing you here is a screenshot from the website to show that you can click on these individual events across the world and learn more about those. So what do these extreme events mean for our streams and rivers? Before we talk about that, I want to remind you that river floods are natural. Rivers are built by river floods. River floods are completely natural in that they are what structure our rivers and streams. They're what build them. We don't see them that often. They cause catastrophic damage to the things that we put on the landscape, but river floods in and of themselves, historically, are what make our rivers what they are. And it's what our animals and plants that have evolved to live in rivers, it's what they have evolved to live with. The problem is that when we increase the intensity of that, when we increase the magnitude of those floods and the magnitude of the consequent droughts and all the other things, the chemical cocktail that those floods bring with them. So we're not going to talk about chemicals today. We're just going to talk about this flood magnitude. And we're going to talk about the magnitude of that flooding as it relates to how we have not only changed climate, but how we change the landscape has a lot to do with how it affects those floods and rivers. Here's a tool that you can go to right now and play around with it as you want, as I'm talking, if you want to. You can go to runoff.modelmywatershed.org. And it's a really simple tool. You can use this. We use it in K through 12 education. We use it to make simple points in presentations like these. But it's a really simple illustration of the way, based on a simple model, right, that actually corresponds with reality of how hydrology and what's on our landscape affects what runs off. So here we're talking about runoff, which is bad. It's what we want to prevent, and infiltration, which is good. So think about a forest. When we put 5 centimeters of precipitation on that forest, all of it's going to infiltrate into the ground if you have really porous soils, right? But if you plant some crops there, now we're starting to generate some runoff, which is bad. We want to keep that soil on the landscape, not in streams. And that runoff is taking away from infiltration. Now, if we put a hardscape surface on our watershed, now we're really pushing a lot of water into our streams and rivers, which is bad. And we're taking away at the same time from the amount of water that's going into groundwater. Remember, the groundwater is our bank account. It's our savings account for saving our streams during dry periods. So as we change our landscape, we're changing that balance between runoff and infiltration. How do we mitigate this? Well, there's 2 basic ways that I've been preaching here, and one is intercepting it and putting it back into the ground. The other is capturing it and treating it. So on the left-hand side, a picture from outside Stroud Water Research Center during a rainstorm. There's 2 things in this picture that I want to emphasize. First is that sidewalk is porous pavers. So the water doesn't run off that sidewalk. It soaks in between the bricks. That's called a pervious paver approach. And on the right-hand side of that photograph, you've got a detention basin. So we capture all of the rainfall that comes onto our property, onto our built environment at the Stroud Center campus, all goes into rain gardens, and it soaks into the ground. There are no pipes, there are no channels, there are no concrete gullies that go into the stream. We can do this on our landscapes. This is possible. We can capture that water and put it back into the ground. Let's go to the middle photograph. This is a photograph from DC Water. So the water company that runs the municipal water and stormwater control for Washington, DC. As with many other cities around the world, these cities are grappling with this very, very big problem. And it turns out to be a very, very expensive solution that they're implementing. Basically, they're digging tunnels underneath these cities that are miles long that capture the runoff and store it. And what you're looking at in this picture are one of these tunnels, and that thing hanging from a crane is the cutting boring machine that bores these miles and miles of tunnels that simply store the water before it can go through a sewage treatment plant, just like we put our municipal waste through. So these systems are incredibly expensive, but they work. And unfortunately, that's what we have to invest in our cities. It's the only way that we found to make a difference at scale. Let's go to our agricultural environments on the right-hand side. This is the worst case scenario for an agricultural field. We're seeing a trampled stream that animals have been crossing through. There's no trees next to the stream, and it just looks like it's in really poor condition. What do we need to do to these environments? We need to plant trees, put the trees back on the landscape, get the animals out of the landscape. And something I haven't talked about yet in an agricultural environment is soil health. Stroud Center and many others are doing a lot of research on how to build up organic matter in soils. And one of the things that does is that it promotes infiltration. It puts rainwater back into the ground and prevents it from running off. So these are 3 different examples of different places where we can change that balance between runoff and infiltration, get that water back into the ground where it belongs. So let's go to a final quiz question now. So based on everything that I've told you, which of these 3 types of conservation practices, we talk about conservation practice as something that you can do that takes water, reduces runoff, increases infiltration, and reduces pollutants. So we're talking about riparian buffers, or better reduced tillage in farm fields, or if you're in a city, green roofs. So let's see okay, and we're seeing the results. Good. So most of you are getting it to link this back to a watershed. Very good. It depends on the watershed you're in. It depends on what's in that watershed, how big your watershed is, and where the problems are. So how do we start thinking about what is best for a particular watershed? We're going to go back to modelmywatershed.org is a tool that, with some features in it, this is really where the great part about this tool really shines, is your ability to do modeling within the watershed that you selected. So for those of you working internationally, I apologize. This feature is not going to be available to you. We're working on that. We're going to bring this around the world eventually as we can. But for those of you who are in the United States, you'll see that in the upper left-hand corner of that screen that you may have opened before, where we were looking at our watershed and the different land uses in that watershed, you'll see that there's a model option. So that model option gives you 2 different ways to model water runoff within your watershed and pollutants like nitrogen, phosphorus, and sediment. So I won't go into more detail than what I've got on the screen today, but there's a lot of detail online that we can guide you to in terms of resources. But the long and the short of it is, we give you these tools to change what's in your watershed and to think about what would happen if I put a green roof on this much of the urban environment. What if I planted riparian forest buffers, or implemented no-till agriculture, or restored forest land to parts of my watershed? So all these little tiles and squares that you see over on the right-hand side, those are all the different conservation practices and land use changes that we allow you to simulate within your watershed. And then the cool thing is that you can compare things like runoff, infiltration, or even pollutants like nitrogen, phosphorus, sediment. Compare the results before and after you implement those changes. And these are predictions. These are predictions of how the runoff would change, in this case, with some different land cover, soil health, and buffers. So this tool in Model My Watershed is really handy for doing this. So again, modelmywatershed.org. We've got some links that are going to come into the chat. Keep an eye out for those that are going to share different ways to use this tool and learn how to use it. But I want to start wrapping up with, okay, let's take this back to the stream. I've shared with you, different types of data and different types of tools and how we think about heat and floods and why these are so important. But do we really have proof that that works? And yes, we do. And you have to wait a long time for this, and you have to keep monitoring. The key to this is dedication to monitoring over the long haul of many decades. And what I'm showing you here is a part of the watershed that we work in at Stroud Water Research Center, where we planted trees decades ago, back in the 1990s. And we watched and measured as those trees closed in the riparian canopy and grew, and we were measuring macroinvertebrates. And we saw over about a 20-year period, we've finally been able to measure the shift of those macroinvertebrates from a system that was degraded towards a system that was healthy. And we're looking at, we want to see those macroinvertebrates restore themselves to the community that used to be there when there were trees on the landscape. So we can see this shift, but it took a long time to do this. So one of the key results here, as we think about this, as we take these messages to our communities, to our different programs that you all are involved with, we can make progress. You have to act assertively. You can't dabble around the edges, but you have to be patient. There aren't any shortcuts. That's one thing that we've learned in all the different science that we see coming out around the world, is that we're looking for shortcuts. We're looking for engineered approaches to make quick change. And we don't see that happening with engineered approaches. We got to take the long view. You got to do the real work in the watershed, not just in the channel. You got to do the real work in the watershed that balances the heat, balances the hydrology, removes the pollutants, and then we have to monitor how these things change over time. It takes decades to get that riparian forest buffer. It takes about 10 years before you can really start to see an effect of that riparian buffer, but maybe 2 decades before you can really see the change in the stream community. Changes in urban streams with stormwater retrofits. Again, you have to have patience. You got to act deliberately and big. You got to go big, but you got to be patient. So we need to be patient. We know we can make these changes. So what are some things that you can do? So contribute to your local municipal land management. If you have the opportunity to get involved in land management, participate, voice your concerns, vote where it's possible, and vote based on what you know, based on what you've learned. Support environmental organizations like Stroud Water Research Center, but there are so many deserving organizations that are doing good science and they're advocating for good policy. So get involved and support those organizations. Volunteer, plant trees where you can, and other activities. Even cleaning up streams is a role that says, hey, we care. We care about what's happening in streams. We want them to look good, but we also want them to be healthy. And then do what you can around your own lawns. We use a lot of chemicals in our environment, even in our own homes and gardens, so we can look at ways that we can reduce that. So one of the things that I want to emphasize here is that you can empower yourself with knowledge. Stroud Water Research Center has invested for decades in this Wiki Watershed toolkit. One of those tools is Model My Watershed that I've talked about. You can learn more about all of these tools at wikiwatershed.org. There are a lot of tools here for you to get involved, to learn, to experiment, and to do monitoring and get involved. So I encourage you to go to wikiwatershed.org and check out these wonderful suite of tools for getting involved and sharing and learning alongside others. So with that, thank you for joining all around the world, for taking the time today or this afternoon, whatever your time zone is, for learning with us about what you can do and learning a little bit about what the Stroud Water Research Center has done. So we encourage you to go to stroudcenter.org, learn more about the science that we are doing and how we're translating that science onto the landscape. So finally, thank you for your time and look forward to questions.
Thank you so much, Scott. And thank you everyone for joining. That was such a great and inspiring and informative session. Thank you all for being here, and I apologize for the fun start at the beginning with the garbage truck. As Scott mentioned, we're opening it up for questions. So if you have any right now, you can pop them in the chat or in the Q&A section. I'm not seeing any right now. And I really think it was Scott because you explained everything so well. Let me just give it a few more seconds. Yeah, everyone's just saying great information, really inspiring. Thank you. Thank you so much. So I think with that, I'll share the last slide that I have. And let's see. Okay. So hopefully after that session, you're leaving with new insights on how watersheds work, how our actions affect them, and how tools like Model My Watershed can help us make better decisions for our environment. Even if you're not in the US, it'd be a great way to just go into their site, see the work that they do. And hopefully in the future, as Scott mentioned, they're working on getting a global version ready. So visit the site to see once that is ready. So now as I show this final slide, you'll see there are 2 QR codes. So go ahead and scan that one that applies to you, whether you're part of Xylem or joining us from outside of the organization. And these QR codes are so you can download your bingo board and get started on more actions. So thanks again, everyone, for joining us, and let's all continue to tread softer on water. Have a great rest of your day. Thanks, Scott.
Yeah, thank you. Great
And we'll see
opportunity
you in
as
the next one.
always.
Yeah.
Okay, so we'll sign off and we'll look forward to touching base with you about maybe doing this again next year.
Perfect. Yep. Thank you again. Bye, everyone.
Bye.